Good afternoon, everyone. And today I'm going to be talking about post-harvest technology to prolong storage life of tropical fruits. And it's pretty much same thing like presented before to right. But mine is more like on post-harvest physiology, and hers more on like post-harvest disease. All right. Okay. How do I? Okay, right. Okay, before we go any further, let me give an introduction about fruit production in Malaysia. In 2022, Malaysia produced around 1.7 million metric ton of fruits, which covers area about 280,000 hectares, and durian account for the largest proportion of the both our planted area and production, followed by fruits like pineapple and banana. Okay, these 10 fruits can consider as the major fruit crops in Malaysia. As you can see here, virtually all of these fruits have reached 100% SSR, which means they are sufficient enough to feed the local and has capacity to for export market expansion. Nevertheless, currently we still import more fruits than we could export. Probably one of the limiting factors of exporting Malaysian fruits is the high, air freight cost, which is about 60% higher than sea shipment. So we need to rely more on sea shipment, but sea shipment take a very long time to reach the destination. That's why we need very efficient post-harvest technology to overcome this issue. So we all know that when we harvest fruits from their mother plant, fruit we also separate them from their food source, from water, energy, and nutrient, and also we create a wound at the site of detachment. And they still keep a respire after they're being harvested, and then by using the stored food inside the body, starch, sugar, until they use up, and eventually they will die. So in post-harvest handling, the keyword, the first keyword is respiration rate. We have to try to maintain, to keep the respiration rate at very low as possible to ensure that shelf life is longer. So the first keyword is respiration rate, and the second is ethylene production, water loss, and also disease incidence. So these are considered, can be considered as the major factors in limiting the shelf life of tropical fruits. And how do we control these factors? This can be controlled through, but not limited to, three post-harvest handling strategies. First, temperature manipulation approaches through temperature conditioning, also freezing technique. Second is modification of the gases around produce through modified atmosphere packaging, and also control atmosphere, and ethylene and water loss control through application of 1-methyl cyclopropene, plastic lining, and also surface coating. So let's start with the first strategy, temperature manipulation approach. We know that respiration is closely related, directly related with temperature. The lower the temperature, the lower respiration will be. So, but that is not as simple as that, because each fruit has their own optimum temperature that they could withstand, especially for tropical fruit. They are susceptible to chilling injury, and as stated in this table, as you can see, Generally, tropical fruits can be stored as low as 5 degree, and most of them in 10 degree. And some can be withstand higher, like a banana. And it also depends on the maturity stage of fruit. Like a durian, if you pick at hand pick, upon maturity, it cannot be stored at lower temperature compared to the one that naturally fall upon ripening. Okay, this is how chilling injury looks like. And one of the simple technique to combat chill injury is temperature preconditioning. So these techniques can be done by temperature stepwise reduction prior to storage. Like we did on a pineapple, we store at 15 high temperature first for first 24 hours, and then we reduce to 10 degrees C for another 24 hours, and then the rest we use suboptimal temperature, 5 degrees C. As a result, pineapple can be stored at a very low temperature through temperature preconditioning, like N36 pineapple, 8 to 9 weeks longer, 8 to 9 weeks, which is 3 to 4 weeks longer than conventional storage. For MD2 pineapple, 3 to 3 weeks longer than conventional storage, and papaya sekaki also 2 to 3 weeks longer than conventional storage without chill injury. So in general, fresh fruits can be need to be stored at the temperature above their freezing point, but sometimes in some cases freezing can be manipulated as a very effective technique to maintain the quality of fruit, like we did in durian, which has a successful history in using freezing to maintain the quality. Like we use cryogenic freezing technique, we could maintain the quality of durian until 6 months. And through cryogenic freezing, we use liquid nitrogen at high velocity to freeze durian rapidly without ice crystallization that could damage the cell. And then we pack in a nylon vacuum packaging and store at minus 18 degrees C, and followed by appropriate thawing technique to get the best quality of durian even after 6 months of storage. Okay, the second approach is a modification of the gas around the produce that can be achieved through modified atmosphere packaging and controlled atmosphere. So for MAP or modified atmosphere packaging, we can be done simply by pack fruits in a sealed packaging, so that interaction between packaging and the produce packaging material and produce respiration rate will create a very low oxygen and slightly higher CO2 inside the packaging, which could reduce respiration rate. Like we do on a banana. This step need to be taken. First, pre-cooling, ethylene absorber addition, and partial removal of air, and followed by sealing and storage at 40 degrees C, which could ensure that no harmful concentration of gases, like 10% CO2. We need to avoid 10% CO2 to avoid CO2 injury. And we need to avoid more than 0.35 ppm ethylene. And also we need to avoid oxygen below than 1% to avoid anaerobic respiration. And for banana variety like musk banana, they are very susceptible to CO2 injury. So we need to incorporate all these steps, including pre-cooling and ethylene absorber, to get more than 6 weeks storage. But for other variety like Berangan, much more simple protocol. You don't need pre-cooling because they're not very susceptible to CO2 injury. Okay, Another application of MAP is has been on starfruit. In Malaysia, starfruit has been long exported to Europe in the form of a mature green stage to be used as a food garnishing. But effort has been taken to increase demand of starfruit in Europe, so that we could promote to sell them in the form of a ripe stage, which has a more appealing yellow color and more the better eating quality and much more sweeter than the mature green stage. So, but harvesting at advanced maturity stage always resulted in a very short storage life. By incorporating MAP, by packing an MAP, we could store starfruit at advanced stage up to 8 weeks. When they arrive at destination, and it turns to golden stage, golden color. That's why we call it as a golden stage, so that can be sold as fruits for fresh consumption, not only for garnishing. So in that way, we could increase the demand for this starfruit. So nowadays, there is an increasing demand of increasing trend of incorporating additional compound inside packaging, like essential oil, to enhance the MAP, like we did on essential oil incorporated MAP in MARDI. We incorporate essential oil like lemongrass to LDPE, so that it will not only act as a MAP, but also it has antifungal activity, antifungal capability inside the packaging. So we don't need to use fungicide anymore by doing this. And it is proven to be effective to pack jackfruit, our jackfruit, in this packaging. So next is controlled atmosphere storage, or CA. Unlike MAP that we could simply pack fruits in a still packaging, in CA we use we can fix constant low CO2 and constant low O2 and high CO2 in an airtight cool room by using nitrogen generator and also gas control system. And for CA, we have developed CA application on tropical fruits like banana, mango, papaya, mangosteen, and etc., as well as durian. And in the slide, as you can see here, CA can be applied on ripe 3-drop durian, Musang King, and could extend the storage life up to 3 to 4 weeks. And at 2% oxygen throughout the storage, it could decrease the respiration rate, and also at the same time did not result in anaerobic respiration. But the need of lowest possible oxygen concentration during storage has resulted in development of dynamic CA. Just now we're talking about static CA. We constantly set the low oxygen at a predetermined safe level. But for dynamic CA, we can set at the lowest possible oxygen level tolerated by fruit by using chlorophyll fluorescence-based sensor. So the atmosphere during storage is can be changing and dynamic rather than being static throughout storage. So we have done, we have developed dynamic CA for mango, variety Chokanan mango. As you can see here, this is the experimental setting for dynamic CA. The black device is the low oxygen sensor based on chlorophyll fluorescence that could detect the low oxygen stress signal. So we do we decrease the oxygen level inside the storage until it reaches the stress point at 0.5%, and then after that we increase the oxygen level just above the stress level at about 0.6%, and then it keeps changing during storage until the end of storage. It could delay fruit ripening and maintain quality of Chokanan mango up to 7 weeks at 13 degrees C, as compared to only 3 weeks under conventional storage. And the good thing about dynamic CA, after 7 weeks of storage, the fruits can be ripened at normal ripening after 7 weeks with a good eating quality. Okay, as you can see here, DCA could decrease respiration rate but did not result in anaerobic respiration. And we also developed the same thing for star fruit, variety B10. As you can see here, the stress point at 1.5 oxygen, 1% oxygen. And as a result, it could retain the green color of star fruit after 9 weeks of storage, compared to only 6 weeks under conventional storage. With maintain a green color and also firmness. Okay, the last but not least strategy is ethylene and water loss control through usage of 1-methyl cyclopropene, surface coating, also plastic lining or wrapping. 1-MCP or 1-methyl cyclopropene has been used to delay ripening of tropical fruits. And in MARDI, we have developed 1-MCP technique for climatic fruits like mango and papaya. For mango, it can delay skin and flesh color changes and maintain freshness, as well as for papaya. And apart from that, we also it has a positive effect also on non-climatic fruit like star fruit. It could maintain the fruit texture and also minimize the black rib or browning around the rib in star fruit. Okay, the next technique is surface coating. Okay, one of the most successful coating developed by MARDI is Nature. One of it is a plant oil-based surface coating, which has no chemical in it and contain essential oil as a tool to combat disease during storage. And this Nature has been proven to maintain fruit quality of dragon fruit, papaya, banana, mango, mangosteen, pineapple, and mango queenie. Okay, in a simulation study that has been done before on a mango sala, we did this in a wholesale market setting at temperature, very high temperature, around more than 30 degrees C. So by doing Nature coating, we could extend the shelf life of Sala mango up to 10 days at 34 degrees C. And this proved that Nature coating can be used as an alternative of for refrigeration, because normally in sometimes in warehouse or local market setting, the refrigeration is not available, so we could use this as a alternative for refrigeration. So another simulation we have done on MD2 pineapple using more advanced maturity stages. Okay, conventionally pineapple being exported by using batches very early stage of a pineapple. We usually harvest at early stage like index 0 and index 1 to ensure that it has a very long storage life. But it turns out that when we harvested at a very early maturity, we have 2 minutes left. Okay, I'll go quickly. So through the use of nature, we can extend the storage life of pineapple that have been harvested at very advanced maturity stages, index 2, index 4, as you can see in this picture. So that we can export them in when they arrive at the export destination, they still have a very long shelf life. At the same time, provide a very good eating quality. Okay, another we also have developed a nano coating using nature through sonication technique to give more effect for jackfruit, because jackfruit did not show excellent result using conventional coating that we have discussed just now. And then I go quickly. And then there is also demand in rapid dry coating, because conventional coating it takes about 2-3 hours to dry before we get them to we able to pack them. So we have developed polysaccharide-based coating, algae coat based on alginate, which could dry as fast as 30 minutes. And also we developed protein-based coating, which is also rapid dry coating. Then last but not least, we also developed a shrink wrap packaging for durian, which also can act as a surface coating, and which could prevent water loss and reduce water loss and ethylene production in the durian. Normally, durian will have a skin cracking even after 1 or 2 days. They naturally rot upon ripening. So we could use shrink wrap packaging using LDPE packaging to reduce water loss and ethylene, so that we can keep a durian that naturally drop upon harvesting up to 3 weeks, right? So now we have come to the end of presentation. Wrapping it up, our efforts in extending a storage life of tropical fruits always comes down to controlling these 4 factors through application of appropriate technology. But the adoption of technology by farmers or stakeholders during supply chain is much more complicated than simply establishment or simply developing the technology. Maybe it could be due to lack of awareness on the importance of post-harvest and a lack of knowledge about the post-harvest technology, and also probably due to refusal to use some available technologies, probably due to impractical technology or too high cost for them. And it's been our responsibility as researchers and also extension officers to educate farmers on how importance of post-harvest, and also to develop technology that suit all the stakeholders' need. Okay. With that, I end the presentation. Thank you so much.